Okay, in this video we're looking at rates of reaction. The rate of reaction is simply the change in concentration over time. So it could be the change in concentration of a reactant, how the concentration of the reactant decreases over time, or it can be the concentration of a product, how the concentration of a product increases over time. The important thing to remember about rate is always proportional, it's always about time. So it's moles per dm cubed, it's units per second, so it's a change in concentration per time. At the start of the reaction, the rate is at its fastest, because that's when we got the highest concentration of the reactants. As the reaction goes on, the concentration of the reactants decreases as they turn into products, and so the rate decreases until eventually one of the reactants is completely used up, so then the reaction stops. Factors that can affect the rate of reaction. Here we've got 5 factors: temperature, pressure, that's only in gases, concentration of the reactants, surface area of the reactants, and the effect of adding a catalyst. Okay, how those factors affect the rate of reaction? Well, collision theory has a lot to do with certainly pressure and concentration, and also surface area, and to a certain extent temperature as well. But mostly these three here, pressure, concentration, surface area, are all kind of linked very closely to collision theory. So what is collision theory? Collision theory is about how molecules react. And the first thing that's got to happen is that for two molecules to react, they have to collide first. They can't react across a beaker, they have to collide, they have to meet. When they meet, they have to have sufficient energy to overcome the activation energy. So the activation energy is the minimum energy they need to react. So they need to have energy above this to react. And they've got to have the correct orientation, because certain molecules only react if they're hit from a certain direction. So if that doesn't happen, they're hit in the wrong orientation, then the reaction doesn't occur. So if we look at the effect of increasing concentration, so there's a little diagram, these little circles here represent molecules or particles. So if we increase the concentration, we've got more molecules, but the volume stayed the same, so we've got more molecules in the same volume when we increase concentration. That means the molecules are closer together. If they're closer together, it means they'll collide more frequently. There'll be more frequent collisions. It's important that you don't just say there's more collisions. There's more collisions per second. That's what you try and get across, or per minute. They're more frequent. So there's more frequent collisions, there'll be a faster rate of reaction. If you increase the pressure of a gas, remember you can only increase the pressure of gases. It's similar to concentration, except rather than adding more particles in, you're just decreasing the volume which the particles are in. So here we had 5 particles, we've still got 5 molecules, but they're a smaller volume. So the same number of molecules occupy a smaller volume. So they're close together, so again there's more frequent collisions. So concentration and pressure are very closely linked.